Everyone. I'm Saeed Jahanmir, President of ASME, the American Society of Mechanical Engineers, and I would like to welcome all of you to this technical briefing. The title of the briefing is Producing Parts with 3D Printing, and this is held in conjunction with the House Manufacturing Caucus, and of course it's sponsored by ASME and the United Engineering Foundation. ASME convenes briefings such as this to provide policymakers with information from subject matter experts in various technical areas to show what these developments mean to the future of our economy, our workforce, and quality of life. Additive manufacturing once was an emerging technology. It is now being used in manufacturing environments across the United States and around the globe. Better known as 3D printing, this new technique allows manufacturers to create products by adding material rather than subtracting it, and hence the name additive manufacturing. This enhanced capability directly enables U.S. manufacturers to rapidly develop and produce a wide variety of next-generation products with geometries and materials that would have not been viable just a few years ago, and especially would have not been viable with machining, for example. This technology is currently in use across our domestic supply chain. It is greatly enhancing U.S. manufacturing capabilities and allowing the U.S. to better compete on a global scale. Our speakers today will provide their expert opinions on how additive manufacturing is being used and provide some insight into the work that the organizations are doing using 3D printing technologies. But before they do, I would like to thank the co-chairs of the House Manufacturing Caucus for hosting this briefing and for their continued commitment to strengthening advanced manufacturing in the United States. Congressman Tom Reed from the 23rd District of New York, who will be here a little bit later on and to meet with us, and Congressman Tim Ryan from the 13th District of Ohio, where America Makes is located, and America Makes was or is the first Manufacturing USA Institute when it was formed 5 years ago, I believe.
2012.
7 years.
We're in our 8th budget period.
Wow. It is because of their great work of Congressman Reed and Ryan and their diligent efforts working across the aisle that we are able to bring you today's briefing, and that our nation remains a global competitor in advanced manufacturing as the industry continues to grow. And with that, let me introduce you to today's panel. First, you will hear from Dr. Tom Kurfess. Tom is the Chief Manufacturing Officer at Oak Ridge National Laboratory, and congratulations, Tom, for your new position, and is currently on leave from Georgia Tech, where he is a professor of mechanical engineering. Tom previously served at the White House as the Assistant Director for Advanced Manufacturing at OSTP. He also serves as the co-chair of the ASME Manufacturing Public Policy Task Force, and he is the incoming governor of ASME starting this June, just a couple more months. Next is Mr. Michael Raphael, the founder and CEO of Direct Dimensions, a one-stop shop for 3D technical services, including product representation and support for all types of 3D scanning, imaging, and dimensional measurement. Since being founded in 1995, the company has expanded to use the most comprehensive array of 3D scanning technologies and digital modeling solutions for the widest range of applications and industries. Michael started in the field of 3D metrology in 1985 as an engineer responsible for solving aerospace manufacturing problems, as what later became Lockheed Martin Corporation. Today, Direct Dimensions employs nearly 30 technical and professional staff and performs hundreds of 3D scanning and modeling projects every year. And our final panelist will be Mr. Rob Gorham, who serves as the Executive Director of America Makes, as I said, the first of the 14 Manufacturing USA Institutes. America Makes is the nation's leading and collaborative partner in additive manufacturing and 3D printing technology with a specific focus on workforce development. Prior to joining America Makes, Rob was the Senior Manager of the Manufacturing Exploration and Development Group within the Advanced Manufacturing Systems and Prototyping Directorate of Lockheed Martin Aeronautics. Now, I think you do have also expanded bios for our panel members, and I invite you to look at those for further background on our panelists' information. Okay, and now let's get to business, and I would ask Tom Kurfess to start us off, and I would also ask you guys to stay on time. I would appreciate that, because we do want to have some time for questions and discussions. And I was told that Congressman Tom Reed will probably join us around 1:10, and he will be, if he shows up earlier, as you know, the drill here is that whenever he shows up, we stop the proceeding and give him the opportunity to address all of us, and then we will pick up and continue after. All right, with that, Tom.
All right, thank you, Saeed. I appreciate it. Let me, so there we go. So I'm going to set the stage on additive manufacturing, really the digital transformation in terms of how these come together. I'm the Chief Manufacturing Officer of the Oak Ridge National Laboratories. Anytime you want to come up to Oak Ridge to see any of these systems, feel free to ping me and we will set up a visit. It is an amazing place, and you'll see some of the systems that we have going on. So let me set the stage. So in terms of how things are going, and not only in technology, but in terms of value proposition and business proposition and so forth. Back in the 80s, right, we had records. I think I see some of you there probably remember, the LPs and so forth. And we digitized them and moved them over to CDs. People said, you'll never replace my record. And sure enough, the CDs replaced it. Maybe we had, 12, 14 songs on a CD. Then we started to get compression. Now we can put, tens, maybe even hundreds of songs on a CD. And of course, we could put them on devices and so forth, and we could distribute it. With artificial intelligence, now you can even just listen to a song, there's Shazam, right, and you know exactly what you're listening to. But completely changed the market space. It took a little bit longer in two dimensions, let's say pictures or video, because, it takes more memory, right? So instead of just, a straight line, so one dimension, we're now in two dimensions, but the same thing happened, right? People did say, you will never replace my Kodachrome. In fact, when I typed this up for briefing, back on the White House a few years ago, I typed in, you will never replace my Kodachrome, and Microsoft, Kodachrome's so gone that Microsoft Word underlines it in red. Right? So yes, that is gone. In fact, when I gave this talk up in Silicon Valley a couple of months ago, I understood the redefinition of the Kodak Moment, right? The Kodak Moment, that's a Kodak Moment, let's take a picture. The Kodak Moment out in Silicon Valley basically means it's the moment when you had your technology, the next generation technology at hand, and you said, nah, I'm not, this is never going to go forward, right? So that's the new concept of the Kodak Moment. And in the 80s, if I would have said name a camera company, you might have said, you might have said Nikon, you might have said Canon, you certainly might have said Kodak or Polaroid, but you wouldn't have said the number one producer of digital cameras today, right, which is Apple. Yep, that's exactly right. So not even really a camera, it's a phone. And just the other one I really love, right, so we talk about videos, Netflix, versus Blockbuster. And so the Blockbusters were everywhere, they were ubiquitous, and now they're gone. Not so much because of the streaming issue, right, that's not where Netflix started. They started because they were distributing DVDs, right? So they could mail it out. They didn't have the brick and mortar type expense. If you think about, instead of a pixel, a 3D pixel, a voxel, right? And so that's why I have my little man up there, right? The 3D voxels. This is the direction that we're going in manufacturing. So the idea, if you think about it, is digital signal processing for your 1D sound, digital image processing for your picture. Now we're going to do digital volumetric processing. And we'll talk a little bit about that. But that's the direction that things are going to go. And I'll give you a couple of examples of that. And really what we talk about is end-to-end, right? Makers to manufacturers. And digital volumetric processing is really going to drive this thing forward. So if we take a look at, where is additive manufacturing? So AM, additive manufacturing. This is some of the work we do in lightweight manufacturing. This is a 3D printer, okay? And it is printing the Cobra, the Shelby Cobra. So this is a car that we printed. And it started a couple of different industries, and sort of very interesting. You could say, yeah, it's we have several different companies that are now printing large scale products. Cincinnati actually is one of the companies that we partnered with. So this is leveraging national labs in terms of really getting new technologies put together, scaled up, and so forth. And we printed even larger things, right? So we've got our Cobra there. Here's a blade for a wind turbine, right? So this is a mold. You can actually make this wind turbine blade. You come over there. We actually still have, if you know the new 777X that's coming out, right? There is a bigger version of the 777, right? In order to make it viable for use in U.S. or in any airport, really, they will have to fit in the standard 777 spots. So what do they do with the wings? They fold them up, okay? We printed the molds for this part of the wing, okay? Right, so off they can go. To give you a feel for something that we've done very rapidly, this is with the Office of Naval Research. We built a sub. We built a complete operational submarine. It's basically week one. We had 25 naval architects come in. And again, you have to think differently. This is not, hey, let's just make the same thing. You're thinking differently now. We're building things up, right? So we're going to make a week of design, 2 weeks to print the sub, and then 3 to 4 weeks to assemble it. Now, this is not a pressurized sub, so this is a carbon fiber composite-based sub. It's not pressurized. What happens to the seals, and this is operation, seals will go in there with their, with their gear and so forth. There are no windows. It autonomously takes them to where they need to go, drops them off, then comes back and picks them up later. But again, completely printed, within 4 weeks, complete submarine. And if you really take a look at this, right, I think people are somewhat familiar with machining, right? We're going to machine things down, okay? So it's this, what you see is what you get in manufacturing. What I have here, there's King Kong, and it's an STL model. STL is what you'll use for 3D printing. And in gray, over there, you see the voxel model. So it's just broken them up into little voxels. Instead of pixels, it's voxels. And what you see there is a progression of machining. So we're using a machine tool to make that. So we can use it in subtractive as well. And what's interesting, right, is you can also use it in additive. And in fact, if you go to HP, right, their additive representation is not STL. So this, the standard problem that's been used by 3D printers for quite some time. They're using voxel models. And they have a very nice conversation about voxel models. They say, oh, look, every one of those little voxels can be different colors. So now I can print cool, different colors sort of 3D models, just like you would have a colored picture when you print it out in pixels. But then they go on to that and they say, look, it doesn't have to be color. It could be material characteristic. I can make softer material. I can make harder material. I can have different materials. I can have different material properties. Conductivity. Conductivity may be electrical conductivity. So I can print wires, right into my plastic parts. So I can make conductivity. I can print thermal, conductivity, right? So I can now have airfoils, right? They could be cooling. And I'll show you a couple of examples of where we might print in some different types of material. So it's not just about the geometry, but it's about the materials. And what's really cool is this is, the voxels, just like your pixels, right? If you think pixels on your screen, and think about your screen, even a small screen of 1024 by 1024, a megapixel, operating at 60 hertz, your GPU is processing on it and moving it around at 60 hertz. Beautiful graphics, and that's a small screen. Well, it turns out the same type of mathematics that you use for gaming, at long last, right, I get even with gaming, right, all my students have all been, playing games, they come in all blurry-eyed. It's actually, very useful for us in the computational area. In fact, if you come to Oak Ridge National Lab, we'll show you the world's most powerful supercomputer summit. This came online a little bit ago. Yes, it will be surpassed at some point in time, but don't worry, we're working on the next exascale machine. That'll be online in the next couple of years. But 97.5% of the processing power is GPU, is graphics processing units, made by a U.S. company, made by NVIDIA, so a partner with us. And then really sort of thinking, out of the box. So I think everybody, well, if you're familiar with the 3D printing you saw was layer by layer, right? So what happens now if instead of going layer by layer, we machine like this going down? What if we could add, right? You could just add this way. And that's what you're seeing over here, right? If I want to put this down, I need something to support it. So I have to put a support structure in, all right? But if I rotate it up this way, I can build it this way, and then I can bring it back down. But now it's not layer by layer, so we have to think very differently. So along those lines, there we go. So here we've got a robot. So you see this is a robot, and it's actually putting down steel. It's got a weld gun on it, okay? And that robot is 3D printing a propulsor for the Navy. So that is a steel propeller, and you can see it there, the finished product there. It's turned on its side. We are printing it. Now we're going to integrate that with machining. Where it's really going to go, it's going to be hybrid. So it's going to be additive and subtractive. So you could machine that down. But now instead of having to machine this big long propeller, I can put down some material, I can machine it, clean it up, get it exactly where I want to go, and then continue to move on. And in fact, with the robot, right, as opposed to your big gantry system, right, with the robot, I can do better. Okay, here's our system Medusa. It's got the little, multiple arms going on over there. That's 3 robot heads and a turntable. I can add more robots in there. Those robots can machine, they can add, we can move it all around. Okay, and we can inspect. In fact, you're going to hear from Michael in just a minute in terms of how do we inspect all those things and how do we move this forward, right? But the bottom line here is it is going to enable us to come up with new designs. So one of the things we're looking at is how do you retrain your workforce, and these would be your engineers, these would be your technicians in your shops and so forth, to utilize and design with this type of capability, right? And then how do you really leverage it to innovate, to get these innovations out into the market space? And so our mantra, right, on our team over at Oakridge, is we are going to innovate, and we will, right? We're going to leverage that innovation. We're going to innovate faster than the competition can copy, right? And you can ask who the competition is, all sorts of different competition out there. But I think that this is the way it's going to go. We're going to be able to produce things faster than it can be copied. And again, when you're going to hear from Michael about, okay, now, we built it, how are we going to inspect it, how are we going to know what it looks like, how are we going to correct it, and so forth. He's got some pretty cool little doodads over there. Probably better than doodads, right? But, and then actually the next one coming along the line is going to be Rob, and he's going to talk to you about really how we are moving this forward with a national effort, right? So these all tie together really quite nicely. But again, the key thing is allowing us to innovate. And do not think about making little plastic trinkets, right? You'll hear about making real stuff. We printed a real submarine. We printed a car. We printed molds for concrete that are now going up in buildings in New York, right? This is the direction that we're going. So real world stuff allowing us to innovate and get those innovations out. Thanks very much for your attention.
Michael?
Hi, good morning, good afternoon, I guess, at this point. Thank you for coming. My name is Michael Raphael, and I run a company just up the road in Baltimore called Direct Dimensions. We scan things. So the key thing to remember is that 3D printing, additive manufacturing, the reason we're here, most of what we're here to talk about and learn about, what you're going to hear about, have heard about, will do more, is all about taking things that are designed in the computer or in the computer for some reason, brought out of the computer into the physical world, right? So that's what additive manufacturing or any type of manufacturing is doing, is making it physical. What we do as a company is we put things in the real world, things look around, we see lots of things, we might have flown here in planes or driven here in cars or whatever, we certainly walked into a building, and we put these types of physical things into the computer, right? It's a digital world, everything that's designed is typically designed in the computer. Whether it's a building for architecture, aircraft, all of these types of things are designed by computers, well, us using these computers. So therefore, if it's a real thing in the real world and we want to modify it and work with it, we have to put it into the computer so we can start from there. All right, so we're going to talk about that. How do you take things from the real physical world and put it into the computer? We do this very broadly with lots of different things, and you'll see lots of pictures of things that I think will make sense to you. So the first thing is, what's the difference between 3D printing and 3D scanning? And these are a couple of facts here. One is, this stuff is a lot older than you probably think. It's been around a lot longer. We've been doing it for 30 years. I developed some of this technology over 30 years ago. 3D printing is over 30 years as we celebrated a few anniversaries recently. Scanning needs to take real-world things that could be of any size, right, including this U.S. Capitol. Scan it, that's a big thing, right? Put it into the computer. But then again, we have jewelry, we have small things, all those things need to go into the computer as well. So there's a range of complexity in the physical world. I'm going to go through a lot of slides. I'm going to go through quite rapidly because I have a lot. And I think you'll see, it'll make a lot of sense to you, and there's a lot of pictures. These are some of the worlds that 3D scanning get into. We are very deep in a lot of these types of worlds, like military and aerospace. Think about it. We've designed a lot of aircraft, a lot of our infrastructure has been designed many years ago. We're still flying in these planes, maybe. Military is certainly a case for this. We want to extend the life of these types of things. How do we do that? Well, they weren't designed maybe 30 years ago. They're barely on 2D blueprints, if you remember those things. So what we do is we take the physical items and we scan them and put them into the computer very accurately so they can be redesigned, redeveloped, new tooling, new parts, and that's where additive manufacturing comes in. But all of these other worlds as well. So these are some of the tools that we use. We've all seen some pictures of printers, and we'll see more of that, but these are some of the scanners that we use. There's a lot of scanners on the market. Scanners for big things, for little things, for complex things. There's consumer-level scanners, there's makerspace scanners in school. We have schools that are using low-level scanners for different things. There's a place for everything. I like to think of it as like the tools in your toolbox, right? No one tool does it all. It takes a lot of tools to do all of the different things that one might want to do. This just shows you that there's a range of application for the scanners that we use, and some for big and some for small. Not meant to be on a chart, sorry. All right, so let's start with some of what these scanners are all about. This is called a CMM, or coordinate measuring machine. And Tom was talking about how we inspect things that we manufacture, whether they're additively or subtractively manufactured. These things have been around for 75 or even more years. And they're in factories and plants all over the country, all over the world. And this is still a way of doing things. It's a robot imaging scanning tool. Think about it. It's a gantry machine. It moves around and scans a part. Very accurate and very automatic, which is a wonderful thing. And you can take very complex shaped parts and scan them. And once you have a scan of a part, you already have a computer model, you can put the two together and you see those colors in the graphs over there. You can get a picture of how it deviates, where the deviations are, where the parts are in tolerance or out of tolerance. There are other types of tools. There's portable tools, tools for doing very large environments like aircraft and things like that. They're your scanners that we can put on robots, as a matter of fact. We can image areas of things, large propellers and ships and subs and things like that, wings. There's even a scanner in that lower blue thing right there. It's on a little robot cart and it goes through the factory. And you can actually pick up and put parts on it and it'll scan different locations in the factory. You need that, okay. This is different types of scanners. There's handheld scanners. We're going out in the field, right, taking measurements out in the field where there might be, gas and oil lines or, complex shapes and surfaces like that propeller. This is a scanner for doing very large objects like vehicles like aircraft and ground vehicles or even buildings. We scan a lot of different buildings. We'll see some of those things later. This is a big one. This is actually a really big technology. We've all seen medical CT. This is industrial CT, right? So it's an excellent application for inspecting and making sure that the additive manufactured parts have quality to them, dimensional as well as structural. You can put parts inside of the CT machine just like a microwave oven almost. It's a legacy part. We want to scan. We may have a blueprint, but we have a part, physically a part in our hand. We want to scan it and we want to turn it into a CAD model. And then now that it's in that CAD format, Tom mentioned STL earlier, that's one of the flavors that we use. Put that right into the system for the additive manufacturing and you can print that part. This is inspection. So this is in more detail. This is what some of the inspection software looks like when you scan a part of complexity like this. And you get these types of reports. So you see the CAD features, you see the tolerancing features. This is critical stuff. This is how you know that things will mate together and fit together and it's critical and important. This is how things are purchased. They have to be inspected and authorized before they can be shipped. Here's some examples here. More complex shapes and surfaces. Again, those what we call color maps, just like a weather map. These are things that we've scanned over the years. A lot of aircraft. There's an example right here. It's a legacy helicopter. We scan. We use some of those same tools you saw pictures of. We can't scan glass, so we put some blue tape on there. And ultimately, we create that CAD model that we talked about. Here it is. Now they can go right to the engineers doing the modifications. Whatever they need to do, they can do from this information. They can't just go out and look at it and say, okay, now what do I do? They need this to do their job. It's critical. All right, so some more fun things that we've done over the years. This guy, right? So it's obviously not in the computer, or it wasn't when it was designed 200 years ago or more. The USS Constellation, it's up in the Baltimore Harbor, and we scanned it just because we could, right? It's historic. What if something should happen? The idea of putting it into the computer in 3D, documenting this historically, and now you have a digital record, a digital preservation, we like to say. All right, ground vehicles. All kinds of ground vehicles that have been manufactured over the years that are not in the computer. There's a truck, for example. Go through, scan the truck, turn that into a beautiful CAD model like this. This is for lots of different reasons we can do this. We do buildings and facilities. Here's an example of a complex factory environment. We scan that. There's another example here. We recently did a project where we scanned this factory environment to turn that into a map of the facility to reorganize and optimize the flow of the materials through the factory. And here's some of the interim analysis that we were doing to sort of map out where all the things were. All right, so we're familiar with this guy, right? So that's Abe sitting in the chair. We got this phone call literally right after 9/11. Hey, we heard you scan stuff. We want to see that. The government, they called. Okay, this was 2001. That's one of the first scanners that could do building level scanning. We took that out to Abe at the Lincoln Memorial, and we scanned Abe, and we ultimately made a CAD model of Abe. And in the lower right there, you see, lower left, you see a 3D print of Abe Lincoln in 2001. And we walked back into the Capitol, to the folks at the architects at the Capitol and whatnot, and said, here you go, here's a 3D print of Abe Lincoln. This demonstrates the fact that if something should happen, right, you remake Abe, right? Makes a lot of sense. We all get this today. However, back then it was, no, that doesn't show me what I need. I need 2D drawings. And we said, oh, okay, we'll come back in a few years when you understand what we just said. Because that demonstrates, that 3D data demonstrates that it can be remanufactured. Does everybody, you all get that today? They didn't get that then. Later, that data was used, because I thought the younger folks would appreciate it. Later, that data was used to make this movie where Abe gets up and walks around. Yeah. Okay, so a couple years ago, there was a big earthquake in DC. Who remembers that? A lot of damage, including this building here, which is the National Cathedral. We got a phone call. We actually scanned many buildings around DC, including the National Cathedral, because they had no documentation. It was designed and built over a 100-year period, and they had nothing. And now they're working with the preservationists and the stone cutters and all this in there. How do we put this back together? How do we document what we have? So we scanned it and did all that. This is a project we did up in Annapolis, in the State House in Annapolis. And actually, I have a piece here that we can pass around. So we actually scanned a piece of architectural molding. We 3D printed it, as you can see here, right? And this was used as a pattern to make a mold to cast others. And they could finish the architectural restoration. There's some others that are made out of nylon material, which is fabulous. This is a capital, it's called, for the top of the columns. All right, who remembers or who knows about, who's local enough to know about Ellicott City, Maryland, a few years ago, had some serious flooding issues. All right, so we used this technology. We walked out and called them up and said, what can we do to help? And we took this scanner and we went into Ellicott City and we took a scan. And here's just an example. You now have all of this measured information that they can plan how to do the restoration and repairs, right? So this is near emergency forensic type of applications right here. Drones. We've all been hearing about drones, I'm sure, left and right. Huge application for what we do related to scanning. How is that? We put cameras on the drones. We can take lots of pictures from things that we image and we'll fly around, and we can reconstruct the photos into three-dimensional shapes. Now those buildings were designed in CAD, and we superimposed them into the scene that was captured from the drones. And it's really an effective way to see what things are going to look like when they get finished, when they get built. All right, get on to mechanical design. These are mechanical parts, things that might be 3D printed, otherwise manufactured. These are all the types of things that we scan and model for inspection, reverse engineering. Here's an application here. We scanned this, you'll see in a second, it's a bridge component, and it was damaged. We scanned it, we made a digital model, as you can see on the right there, We 3D printed it to fit check it to confirm that it would fit and work with a little plastic printer, which can be effective for something like this. And then it was ultimately manufactured out of metal and printed and fitted perfectly, demonstrated, all in a matter of days. Consumer products, all of these types of things, and I'll show in a second some reasons why this is becoming really popular. Really the key to think about additive manufacturing as it relates to consumer products is mass customization. Remember that. That's the idea that we can get one-offs of things that we need, that we want to wear, clothing, apparel, wearables, or medical devices, things like that, that can be manufactured using additive manufacturing as a one-off to fit you custom, you personal. And these things are coming, and I'll show some examples of that in a second. Clearly, a lot of art and sculpture is not in the computer, is not in 3D, right? We've done a lot of these types of things, including there's sculptures outside here today that we've scanned over the years. Medical, we'll go through some medical applications. There's a lot of application to additive manufacturing in the medical space. The idea of making braces, splints, and orthotics, custom implants. There's a few things floating around. This is even a surgical guide, right? So the idea is you can put this on in surgery. We made this a few years ago. It's really used in a surgical case. And it was placed over the patients, and it's literally for an ear prosthetic. And there's little holes here where you'll see them. I'll pass this around. And the idea is that the surgeon now knows exactly what the trajectory is for the hole that he needs to drill in your head, right? So that the screws that hold the ear on are appropriate, right? Yeah. There you go. All right, here's an ear prosthetic case right here, and you'll see that's ultimately, and this may have floated around, the idea of making a prosthetic ear. No one wants to wear the plastic, right? No one's going to wear that. So we recast it. You may have seen it as silicone, and that can be tinted and colored. There's actually now 3D printed silicone, which is just coming on the market. We're really excited about that. Over the years, we've made a lot of things with 3D printing for custom components. The idea of fit specific, right? So this is helmets for aircraft pilots. What's more important than that? That's important. All right, and I mentioned this earlier. This is the idea of mass customization. A couple of headlines I just grabbed the other day off the internet, right? The idea of this Fleet Feet. You might have even, maybe you guys are customers. They scan your foot. They make things for you, fit you. The one below, the next thing that we're going to start seeing is eyewear. Custom 3D printed eyewear. There's even a company making 3D printed lenses. Watch for that. All of this is coming in a big way. Here's an example of a project we did where we actually built the scanning system to capture people's faces, put that into 3D very accurately, and then dimensionally you can size these faces, size the eyewear to fit the dimensions of the face. This is all coming. Braces, as I mentioned earlier, this is a fellow who has had a stroke, and we're making him a custom brace. Other things that might be done, and this is kind of different, and sometimes you have to get out and do things to demonstrate the technology, right? We demonstrated that by scanning our Governor Hogan, out of Maryland. And we scanned him, and then we 3D printed him, and made very interesting things for him. And he was thrilled to see that. It demonstrates it, right? It puts it in our face, so to speak, right? All right, so over the years, we've done a lot of people scanning, and we've specialized in some of those applications, and some of this gets into some really fun stuff that we do. But some of it's very, very serious for some of the national, the federal labs that are around here, like Pax River and Aberdeen Proving Grounds. We've done tons of work with those guys to make better environments for our group. But we also do these types of things, and we support scanning. We use the scanning technology to help make the movies that we've all seen, and we see all these special effects in the movies, and a lot of that's done in the computer. But this boat, for example, was scanned for the movie Walter Mitty, if anybody remembers that, as well the helicopter. And you might recognize that guy who was in the movie, right? Isn't that fun? Yeah, we get to do this stuff. And that young lady as well, who was in the movie. All right, so that's a glimpse into 3D scanning. I hope that helps understand some of the applications of the technology, and it makes it feel interesting. And I'll pass these things around as well. Now, I guess next, we have Rob.
All right. Good afternoon, everybody. I'm going to try to relate all the things that they're doing to the opportunity we have in the United States, specifically what I'm chartered to do at America Makes. And so it's going to be a little different. I'm not going to show you a lot of pictures of what printing does or scanning does, but I'm going to show you some of the opportunities, some facts and figures, what the economic opportunity is here in the U.S., what the workforce opportunity is here in the U.S., and hopefully can bring some context around what these gentlemen have brought, which are some very exciting exciting opportunities to think through. Before we do that, some of you are familiar with American Makes. Talked a little bit about it. Does everyone know about American Makes? Yeah, good. So we are familiar with the fact there's 14 institutes. President Obama made a State of the Union address and talked about the importance of it back in 2012. What we are is a public-private partnership, and what that means to us is that we have 230 organizations all working across the United States to try and address gaps and technology gaps and workforce gaps. And so we've been able to partner with the Department of Defense, Energy, Commerce, NASA, the National Science Foundation, Food and Drug Administration, and the Federal Aviation Administration. And with all of these different organizations working directly with us, we're trying to extract what it is they're ultimately looking to get out of these technologies, prioritize in a way that's effective, and then hopefully move this technology forward so that we can actually start seeing the impact in our day-to-day lives. Our vision is this industry. It doesn't really matter. The point is we all have challenges to get these things certified, to get these things verified, that the quality of the 3D printed part actually meets the design intent. And so by bringing everyone together, we can drive some consensus around approaches. And we are a platform to do just that. We're sponsored out of the Department of Defense, as I mentioned earlier, but we work across all public and private organizations. You can see here that we have quite a few partners. And while I did mention, I think we have 230, we're continuing to grow. And that's an exciting thing because, as Saeed said, you know, maybe we're only 4 years old, but we're actually getting ready to get into our eighth, you know, we're in our 8th budget period. For us, that's very good. These institutes were set up to be sustainable after 5 years. And so for us, I think we've been able to demonstrate value to the members with which we interact with, to organizations across the country, to people like yourselves, and continue to operate as a public-private partnership. But I think it's important to look at something that's interesting, and that is what many are calling the verge of the 4th Industrial Revolution. I'm not going to get into the debate as to whether we are or we are not. But the point is, cloud computing, digitization, the Industry 4.0, augmented reality, all of these things are starting to converge. We're starting to see a convergence between the physical and digital world. And I think 3D printing demonstrates that probably better than anything because it does allow us to take advantage of things that Oak Ridge does, like in their supercomputing technology, to what Michael's talking about being specifically scanning. But you get into a lot of material development, you get into gamification of the 3D printing technology while trying to train students in K-12, so there's a lot of really interesting things that are happening. And because of that, we're starting to see a really big opportunity for us in the United States. A report by the World Economic Forum published a couple of years ago said that the global economy to the tune of $100 trillion can be disrupted with 3D printing in the next decade, and that they are expecting 3 to 5 million jobs are going to need to be filled here in the United States. Well, that's a serious problem, and because we don't know where those jobs are going to come from. And so, you know, we've been working with Congress, we've been working with our membership, we've been working with other public organizations to try to help understand ASME, for example, like what do we need to start deploying in some type of a standardized way to get our workforce to be capable of taking advantage of and being competitive relative to the rest of the world. And so, you know, that's a big challenge for us. In the future of 3D printing, it's not just these one-off parts, but it's actually starting to integrate the technology into more of a system-level thinking. And we're going to start seeing things like, and I'm glad you brought up these pictures, you know, consumerized, on-demand manufacturing solutions that are specific for us. You know, the last 10, 15 years, I think we've been sort of blessed and spoiled that everything we want, it can be customized for us. And I think, you know, it's not just about the clothes that are being tailored, but now we're going to get to start seeing things in trains, planes, and automobiles that hopefully can too be customized for us. And I think that's really exciting. We're seeing that with Additive now and some of the other shoe manufacturers who are trying to take advantage of the differences with which we all sort of operate, whether you're a football player, a runner, or just someone who walks up and down Congress every day. It matters, right? And right now we don't have those opportunities. And so the other thing is that we're going to start seeing some really interesting transformation with the way things are being built. Instead of taking a box of Legos and doing some of the assembly like we're all used to doing, you're going to get to start seeing whole systems be manufactured. So when Michael does the scanning, you can actually go and manufacture that system. And you saw the Cobra Shelby as a good example. And I think the other thing, and I'm out of Youngstown, Ohio, and so obviously we've all been following the news and what's happening with General Motors in Lordstown, and that's just devastated our area. And what's awesome about 3D printing is there's a blessing in all of this, is that it's allowing us to rethink how manufacturing is to be distributed in sort of smaller outfits in more regional pockets around the country. So we don't have to assume that with business and market volatility that we have to shut down full plants. And so hopefully we can start thinking through de-risking sort of the manufacturing supply chain by using things like 3D printing, connecting the digital world together in a way that's effective and productive. And the graphic that I'm showing here, by the way, the last 3 graphics are courtesy of Hewlett-Packard. They actually did a study with A.T. Kearney. And I would recommend, if you're not familiar with some of this opportunity, you go Google A.T. Kearney HP 3D printing. The first thing that'll pop up is a report that's really, really good that talks about all of these graphics. But the point is sort of distributing local manufacturing we think is going to be very, very important in the future. The other thing, and we're talking about education and workforce. If you look at the picture on the right-hand side, you'll see what we have, which is in purple, the design engineer, the manufacturing engineer in orange, and the specialist engineer in blue. And what we're starting to see is the need for the design engineer to not just stop at prototyping, but actually start to get engaged with production of some of these systems. And so human resources at GE, for example, are calling us saying, we don't know how to put out a job requisition to hire talent, and we don't know if it exists yet. And so fortunately for guys like Dr. Kurfess at Georgia Tech, we can start thinking about making sure our students coming out of schools are prepared to take on these new jobs, because it's not just the jobs in the past that are going to support us moving forward. And I love this picture because we did a project with NASA several years ago where we were looking at trying to think through how we would actually deploy habitat on Mars using things like 3D printing, but taking advantage of the materials on Mars. Like, how do you get lumber to Mars, right? It's impossible to do that. And so can you use the 3D printing process, the energy that's existing on Mars, and the raw materials that's there to start 3D printing in space? And we captured this kid's imagination, and I think it's important for us to realize that all of us can be dreamers, and fortunately for us, we're now able to print what we dream. But the problem still exists in that just because we can print it, it doesn't necessarily mean that it's going to meet the intent of something that's really complicated. And so for the next 3 charts, what I'm going to show you is I'm going to kind of relate the 3D printing design parameters and sort of the flexibility of this process to a color wheel. And the point is, and Dr. Kurfess brought up HP and the voxel and being able to control very specific points in the 3D printing build, that while traditional design parameters are somewhat discrete and quantized, you don't see a lot of continually varying degrees of customization within the material, for example. So the microstructure, how the material looks inside if you chopped it up, is right now when you manufacture it through machining is standard, right? And so the ability to change flexibility or functional performance or change some type of electromagnetic reason for doing it, all of that now is being able to be done through these 3D printing technologies. And so we can truly start to customize in a way that's never been done before. And you can see here we actually did a project with Honeywell and with the Department of Defense where we were printing heat exchangers. And that's not a new concept at all, but the takeaway here was how long it took the designers to think through using these fancy tools that exist, how to actually take advantage of the tools that exist by thinking in 3D. And that's still an opportunity that I think is that we have to face and deal with. And then lastly, what I'm saying here is that I think additive manufacturing is starting to disrupt key assumptions. And this is, I don't know, do y'all work with Local Motors? Yeah, so this is a Local Motors car, I believe. And you can see here that this doesn't look like, if you took the body off of your F-150, it's not going to look anything like what you're going to see today. And that's, again, what's really great about 3D printing. So what is this crazy graphic? And how did, like Saeed say, how are we helping to bring the ecosystem together? This was a $2 million project. To some that might sound like a lot of money, but it's really not in the big grand scheme of things with the investments being made in 3D printing. And the point here is that America Makes serves as a platform to bring all of these different folks together to actually work on solving that problem. And that is very, very powerful. When we get John Deere working with Ford, and we get to pull together Oak Ridge National Lab or Direct Dimensions or whoever and start to actually build that ecosystem so that when we solve the problem, it's ready to be deployed, that's the power of what I think the platform of America Makes can do for all of these different approaches that are taking place in the ecosystem. This guy's name is Easton LaChapelle, and I don't know if any of you have seen this gentleman or not, but he decided that he was going to change the way prosthetics were manufactured. And at 11 years old, he started his own company. And that's really interesting because now, fast forward he's in college and he was getting scholarship offers all around the country, and he decided to stay home in Colorado because he felt like, to my point earlier, he could actually start a business, still support sort of national initiatives by taking advantage of taking advantage of the 3D printing process being accessible, learning on his own, and starting his own business. And these are the exact opportunities that everyone is being able to take advantage of today. So obviously, this is just the last thing I would like to say, to be honest with you, and it's this quote from Albert Einstein, that we can't solve our problems with the same thinking we used when we created them. And that's really what guys like these gentlemen are doing for us. And again, my platform is to bring all that to a conversation that is taking us to the next step. And this was one other photograph that I took at the end of that NASA competition, just again, wanted to leave us with the thought of how do we imagine dreams and actually start manufacturing in a way that's going to mean something for the United States. Thank you very much.
Well, thank you very much, gentlemen. This was really very exciting. And, you know, sitting here listening to the presentations, I started thinking that back in high school, I had 1 year of engineering graphics. And then in college, I had 2 semesters of engineering graphics. I learned how to do blueprints by hand. I learned how to do 2D drawings, and then try to imagine what it would look like in a 3D, right? And now, I'm not going to say how many years, in just a short few years, we've gone from that to this. And I think it's really scary to think about what you will experience 30 years from now and what the technology will be like 30 years from now. In just a short 30 years. And what is really required for these things to happen, of course, there is innovation, ingenuity, but we're here in Congress. Federal government has a big role in making these things happen. Because industry, of course, does push things along, but they cannot take too much risk. Federal government can start some of these activities and make it go. Well, with that, I see my good friend, Congressman Tim Ryan is here. Congressman Ryan is co-chair of the Manufacturing Caucus, and he's been a co-chair of Manufacturing Caucus for a few years, and he is one of the big supporters of manufacturing, technology, and engineering, STEM education, and many other activities, and of course the veterans and DoD activities. And I had the honor of working for Congressman Ryan.
Yeah, we had Said for 1 year and then came back for another year, so we were blessed to have him. I'm just going to say a couple things. One, I love Rob Gorman. Just heard. He's the whole idea of President Obama's innovation institutes around technologies, and Rob mentioned what's happening in Youngstown, Ohio. We had a business software incubator in downtown Youngstown, and it had been, for the longest time, a real light in the middle of a old industrial downtown in the Rust Belt that had been dilapidated, and and then that brought some life. And then we got America Makes to come in. It really injected a lot of energy into the downtown. Partnerships with Youngstown State University, public-private partnerships coming in from industry, and they've taken what is now called America Makes really to the next level. And we've got a lot of work to do, and so I'm glad you're here because we've got to build, it's interesting how your days go, but I just came from a classified briefing with the National Security Agency around China. And then you hear about what they're doing with 5G. You hear the billions and billions of dollars they're putting behind artificial intelligence and all of these areas in the United States, in universities in the United States, in addition to what they're spending in China. And the fierceness of the competition that we're in, I think, gets lost in the political discussion down here about Mueller and Russia and this and that. And it's like you live our daily life here on the Hill, and then you turn on the TV, And the disconnect is so profound that it scares the shit out of me, to be honest with you. And so that's why we have got to stay focused on the work that's happening here, because this is the future. This is what we have to be doing. We have to create the pipeline. It's got to be K through 12. It's got to be 2-year degrees. It's got to be 4-year degrees. It's got to be PhDs. It's got to be in all of the different industries. It's got to be public-private partnerships, all pushing in the same direction. I'll just leave you with this. The one thing you see with China, and I know we have our inherent advantages in this country, obviously. What they have and what they're doing now with using a whole of government approach is something that we have got to get back on track with, because we had that, like post-World War II, we came out, we had the GI Bill, we had the interstate highway, we had housing, we had, we're taking care of our vets, getting them educated, we're rebuilding the country, water, sewer, Tennessee Valley, I mean, just keep going from like World War II on. We had this big comprehensive plan, Marshall Plan, we were like NASA, we were all like, we're going all in, we're gonna dominate the world economy and lift everybody up, cut workers in on the deal. Now, China's doing that. Belt Road Initiative, I saw a map the other day, it had a rail line going from northeast Russia to Rotterdam. Bases in Africa, redoing ports, going in, buying off countries in Africa, signing long-term raw material contracts, infrastructure, military, South China Sea, bases on the islands. I mean, make it in China 2025, we could do a whole session on just that. And we're over here kind of trying to piece it together like MacGyver, with bubble gum and shoestring. And these are the kind of things we've got to invest on. It's not a partisan issue. This is about the future competitiveness of our country. This is about making sure we have a middle class. This is about making sure we reinvent and put some energy into some of these older areas. This is about all of this. Walkable communities, because what's happening in downtown Youngstown is bars and restaurants, and there's some nightlife going on. Force multiplier with public spending. That's what this is all about. And I think you probably told him 3 to 5 million jobs. And yeah, see, I know all his stats. I just steal his stuff and just repeat it. But 3 to 5 million jobs, additive growing, by 25 or 30% a year. And you look at what China's doing with electric vehicles, they dominate 40% of the market. With solar panels, they dominate 60% of the market. We've got to start leapfrogging them and getting our act together, and it starts with this kind of focus here. So thanks for being here. Sorry to get on the soapbox and rant, but I'm Irish and Italian. That's what you get. So thank you so much.
Thank you, Congressman Ryan. Perfect timing.
Hey, Ryan, there he is. I just warmed up for you.
Oh, perfect.
Did you
Well,
cover? What's that? Did you cover? I think so. Acted like a senator.
Talking about bipartisanship and the spirit of bipartisanship, especially when it comes to manufacturing and technology. And I must tell you, yesterday I was at a hearing organized by Science Committee on manufacturing. And the spirit of cooperation across the aisle from both sides was amazing. And there was nothing negative I heard yesterday. Everything was positive. Everyone was really positive about advanced manufacturing. Well, Congressman Reed is co-chair of Manufacturing Caucus. And I had the pleasure of working with him and his staff when I was here. And again, as I have to tell you, bipartisanship. I was in the Democratic office, but I was working very closely with Congressman Reed's office. And our staff worked across the aisle, very, very closely together. And as Congressman Ryan said, what you see on TV is not what's happening in here. That's completely different. Fiction or fake news or whatever you want to call it. I just want to leave you with one thing. I've heard that Congressman Reed is one of 12 children And when I heard that, I cannot imagine what went on in your household every morning. And that he is the youngest, and I hear you have many sisters that take care of you, or did, and probably still do.
Still do.
And so with that, I'd like to welcome Congressman Tom Reed of New York.
Thanks, Saeed.
Well, thank you, everybody. Thank you, Saeed, for the introduction, and thank you, everybody, for allowing me to crash your party. Following Tim Ryan, I don't know what to add other than to say everything he said, ditto. I'm sure it's the same thing. And that's a Democrat-Republican agreeing. And that is good to hear in the Science Committee that there was a lot of positive talk, because there should be a lot of positive talk. You know, I've been bullish on U.S. manufacturing since the day I got here in 2010. And I got to tell you, as we see the jobs report, 493,000 manufacturing jobs being created, we see the U.S. steel industry blossoming again. There was a State of the Steel Industry report this morning, and we're starting to see where we're getting those supply chains. We're starting to manufacture those things, starting to build it here again in America. It's exciting. It's exciting to be part of it. And so Tim and I work hand in hand together on these issues, because there is a lot of common ground when it comes to manufacturing, U.S. manufacturing, and the growth that's associated with it. And you know, and we don't lose sight of the fact when we talk about growth, we talk about these numbers. These are real people. These are real people that get the dignity of going to work, earning a paycheck, and bringing it home back to their household, so that the next generation is a little bit better off than which maybe they find themselves in their own homestead growing up in a household like mine. You know, youngest of 12, you point out, and I do have 8 older sisters, 3 older brothers, and in the morning I never got a shower but once a month, it seemed like. The girls were in there all the time. I never had a chance to because it went 8 girls, 4 boys. It went in that order, to be very honest with you. So us boys, that's why we probably lost our hair and looked like this and everything else. But I learned early on, you know, in that environment, you know, that you work together. That's when you're the strongest. We're one family, and the U.S. manufacturing family in particular is united. And so we come here on the cutting edge of such innovation, 3D printing, the stuff that you're talking about, is my understanding today. It is the stuff of advanced manufacturing, is the heart of tomorrow's manufacturing, and we're going to do what we can to stand with you guys in regards to developing and creating that advanced manufacturing for generations to come. And one last thing that I always try to stress is that I'll be a voice for manufacturing wherever I go. And it happened again here recently. We just had a break this last week, and I was at the local high school. We go to a lot of the high schools in the districts. And you know, we were promoting, you know, the whole vocational area, the whole issue of welding, of HVAC, of plumbing and heating, and the $50,000, $60,000 starting wage there. And after that whole conversation, I had an individual come up and you know, tell me, you know, Congressman, that's great, but we really, unless some substance of what he said was, we really don't promote those jobs here. And I would just tell you, we have to attack that stigma. We have to get up every day and be proud of what we stand for in U.S. manufacturing. Tell folks what it is, what you know it to be. High-tech, advanced, safe, clean, cutting-edge type of skill set. And you know, we're going to change that stigma, but together, it's going to take all of us doing it together day in and day out. So without further ado, I'll give it back to you, Dave, and just know we're in your corner. Keep up the great work. Thank you.
Thank you, Congressman Reed.
All right. I'm going to go find that science committee and not get yelled at anymore.
Excellent.
Good to see you guys.
As Congressman was saying, you know, manufacturing jobs today is so different than manufacturing jobs of 30 years ago. And in fact, you see more computing power and more computers in manufacturing environment today that you will see at a university classroom, for example. And when you go to manufacturing sites, and Congressman Tim Ryan used to say that you can practically eat off the floor, and that's not the way it was 30 years ago. And then the picture of manufacturing in which a whistle blows and 5,000 people walk into a plant, and then the whistle blows 5,000 dirty-looking. I said question. Dr. Hong Man in the back has a question. Please introduce yourself just very briefly, and if you have a question for a specific panel member, please state so. And if your question is for anyone on the panel, also say that. Hong.
Hi, my name is Hong Liang from, right now I'm an ASME Congressional Fellow, work with Saeed in the Advanced Manufacturing Office, and also back home I'm a professor of mechanical engineering in Texas A&M. I have two questions. And the first question is for Mike and Tom, is about, do you have any comments about the defects after the 3D manufacturing, additive manufacturing, so defects of materials? And the second question really for Rob, can you comment about, because right now the 3D printer is very easy to make. My students just spend the $50 by part, put it together, print a lot of stuff. So do you see the pop mom store, they can, a lot of people can print a lot of stuff. Where do you see the manufacturing at home? How many printers everybody's going to build, millions or something? What's the trend for that? Thank you.
Yeah, please repeat the question for anyone who might have not heard the question.
Okay, well, so the question was really what about defects in 3D printing, and you could imagine, people, the idea is, let's say I'm going to make a turbine blade, right? And you say, well, hey, we've been making these for a long time. We cast it and so forth, and we know what's going on there. Then we machine it. I 3D print it. I could maybe put some pores in there, maybe not get the right, material configuration in there and so forth. And it's sort of that's actually, it sort of goes back to, I forget who was talking about this, but it's a little bit of that thought process is now very different. So again, you have to get away from geometry. So you have 3D printing, cool geometry and so forth, but we can now control material characteristics. So actually, as I'm 3D printing a turbine blade, I can actually print in and know the characteristics. So we call this born qualified. So this part is born qualified. And in fact, what we're going to see, we're actually doing a lot of work with Delta Airlines, for example, and they do a lot of engine repair down in Atlanta. What you're going to see actually in the next probably 3 to 5 years is people will not want to have the classically made turbine because you don't know. That turbine blade, you don't know what's in there. You're going to want the 3D printed one because you know exactly what's coming out of it. And by the way, with the hybrid, where you're putting material down, additive and subtractive, you know what? If you do some inspection, and I bet Mike can talk a little bit more about that. Michael can talk a little bit more about that. You're doing some inspection. If you don't like something was put down, you could just erase it, machine it off, and put something else in there. So I don't know, Mike, you want to add to that?
Well, and right on that one, exactly. We're doing some work with the Navy right now. We're doing some work with the Navy right now. You might find this interesting. It's one thing to inspect, and you saw some of the images of the color maps that we like to call it, with the deviations, sort of like a weather map where you see the highs and the lows, and whether the contours are exactly what you want or not. And that's important, right? I mean, things have to fit or perform properly, and these were designed in computer simulation environments, and we need those parts to be produced exactly. My point is that we're actually working with some folks to not only do the inspection, right, to get that dimensional information, that analysis, those results, but to also use the technology of what's known as, you've probably seen it, augmented reality, right, to reproject this information directly back onto the surfaces of these objects. So you can now go to those objects directly, feel them, touch them, see them, measure them with maybe other tools, and confirm that this is exactly where those defects are, right? So now you can repair them. The workers can actually go, they know exactly where to repair. Maybe they just need to take a little material off or put a little material back in. And it's a very precise way of putting this all together. So this is happening with additive manufacturing as well as conventional manufacturing today.
Okay, the question was about what does the future look like with the ease of access of 3D printers and being able to basically have anyone do it. And this is what we've been seeing, and this is what we've been sort of suggesting. When manufacturing things today with traditional means, there's a lot of deliberate steps that go into thinking about how you're going to make it, and how you're going to inspect it, and how you're going to actually implement it. The challenge with 3D printing is, to your point, anyone can do it. And often people say to me things like, well, knobs on ovens or handles on doors don't really matter, so let me just go make it, until they do. Right? If it breaks off and you can't turn your stove off and it's pumping gas, it matters. And so the challenge I think we still have is ease of access doesn't mean quality. The Department of Navy is working with us right now at the admiral level because they believe the future of 3D printing and accessing 3D printing is exactly what you suggested, the mom and pop shop. They want to see that distribution around the country, the world really, because it's easy to deploy answers, right? When they need to do something, they can do it. We at American Makes are trying to make sure that, like the chart I showed earlier, that we bring everybody to the table to start putting some kind of a standard around what quality means, so that when your students or when someone in a Kinko's shop wants to make something, they're doing it against something that matters. That's kind of what we see. Yeah, I think the future is going to be that we think every engineer should have a printer next to them when they work at Lockheed Martin. But I still think there's a long way to go on what that ultimately means beyond just prototyping and learning aids.
If I could just add a little bit to that, and I agree completely. I mean, the idea for schools and libraries and clubs and ab labs to have this type of equipment for learning is invaluable. I'll add that we've been working with, ultimately it's through the Navy as well, an applied physics lab just up in Maryland to field and develop these kits. They're kits that are going to have, and they're being fielded and deployed as we speak. Printers, scanners, laptops with some software, CAD software, and they're basically deploying them out into the field, right, for the Marines and whatnot, to learn about these technologies, to at least to fix problems out in the field that they may have. But it's really less about probably solving the world's biggest problems and making sure these vehicles can go or whatever they might need to do. It's more about them learning these skills, learning this capability, learning that they can get this type of thing, or if you can leverage these types of tools to let the professionals ultimately solve those problems. Maybe they will come up with some great solutions and feed them up the chain to work out real big problems that started from a little printer that they were able to do in the field themselves.
Yeah, thank you. I see another hand in the back.
Hi, I'm Seth Aguilar. I'm a AAAS fellow and I place at the National Science Foundation. I have a question because I saw years printing, and so I did grad work in 3D printing cartilage. So one of the challenges that we see in 3D printing with the biomedical engineering field is to make it with cells. When you're mixing it with cells, the material and things. So I just wanted to see what is your vision, your thoughts on making this technology available in manufacturing at large scale, because at the university levels is very in its infantry or medium infantry.
So, the bios, certainly out of my area, but these are things, right? I mean, look, when you're looking at either the metal or the polymer 3D printing, right? I mean, the first thing you do is you heat it up, you melt it, and off you go. That's not going to work particularly well with bio, right? But some of the interesting things, so actually building the scaffolding to grow the biomaterial, in. So some of that is actually non-biological, or you can have biocompatible material. But I think that again, that's one of these areas where it's quite interesting, and we have a number of institutes, that are similar to America Makes in this area, where they're saying, how do we do that? Whether it's repairing, damage, let's say, to a warfighter, or actually starting to build some of the artificial, organs and so forth, and how far can we go? But it's a completely different way of thinking about things. And I can tell you, without additive manufacturing, we would need to be close, right? So this is not so much about, the real problem here, in my opinion, is more the materials and handling and the processing. I think a lot of the tools, the CAD models and so forth, the geometry is there, but now it's going to shift over to the material side. Again, I don't know much about that aspect of it, but it basically really highlights the fact that, we're talking about, hey, as Rob said, every little voxel, you can change it around. Now imagine if you could do that with biological properties and so forth, and you could tune it for specific needs. Mass customization. Not everybody's going to need the exact same part, the exact same liver and so forth. You can mass customize it to really meet the needs of the patient. And additive just enables that.
So we have been asked a lot at America Makes, well, you must certainly do 3D printing of biomaterials, right?
Yeah.
Well, fortunately for us, the Department of Defense decided to invest in an institute to do it. It's called BioFab USA. They're in Manchester, New Hampshire. And it's called the Advanced Regenerative Manufacturing Institute. Dean Kamen, the inventor of the Segway, is actually the executive director of that. So if you are interested, I would suggest that you either see me and I can put you in contact with that institute. But there is one that's thinking about how to make it happen.
And in fact, I think we're going to have a briefing coming up in 2 weeks. So April 10th. So watch your emails, and if you're not on the list, make sure you add your name to the list. And Dean Kamen is an outstanding speaker. He is a storyteller. And when he starts talking, he captures your attention and you're listening to him until he stops. And he is just absolutely outstanding. Okay, another question. Yes, please.
Hey, I'm Matt Davidson, a Science Policy Fellow at Research America. And thank you for your talk. You talked about a pretty wide range of applications, like planes, and medical, and industry, and personal. And so the two questions I have is, what do we need to get, what do we need to do to get from this sort of industrial scale to like you're talking about being able to do everything in your home or these distributed mom and pop shops? And what sort of regulations, what are you working on to make sure that people are able to do that? And I'm particularly interested in, I know with copyright, a lot of companies are saying, well, you can't repair our stuff, you can't make your own parts. So how does that idea fit into this distributed manufacturing idea?
I don't mind, I'll kick it off. So I think the reality, I think the first thing, in terms of a lot of these advanced printers and so forth, it's not that you hit the button and the part pops out. So there's actually a fair amount of skill and labor. So number one is, there's a big fallacy if people say, oh, well, this is going to, our factories are going to be empty, so you're popping parts out automatically. So I think this issue of, having things printed out at home, for industrial scale, probably not a super close reality, but in the mom and pop shops, I think that is the capability, because they do. If you go to these shops, they have some pretty high-tech capabilities and so forth. So I do see that moving along. In terms of copyright and so forth, I think you really need to start to rethink how this goes. I'll bring up again, the whole Blockbuster and Netflix type of thing, right? Now we're talking about shifting from, okay, you got to buy the DVD or rent the DVD to we're going to stream it for you. And even more recently, that was a big advance when Netflix started saying, was it Netflix?
No, it was actually really neat. And I think that's what we're trying to do at American Mix. Again, that's the platform which we're trying to create.
It's very important to make a note that a lot of these issues will get settled eventually. And unfortunately, many of them require policies and standards. And more unfortunate than that is that it takes a lot more time to develop policies and standards compared to how fast the technology is moving. In the arena of standards and regulations and policies, it's impossible to stay ahead of technology. We're always behind it, and we always react to it rather than predict what it might be.
And I'll just add that one of the things that we really have to be careful of is not to come up with the policies to block this. So, hey, this technology, we've got to stop this because China will not stop. European Union will not stop. They're going to move it forward. And let me just add this. So, yeah, I want to buy the part from GM. GM would be so happy, right, if they didn't have to keep the raw materials, pay the people to make it. They could just email the file to somebody else to make it for them, and then they could just reap the profits. The profit margins are huge in that case, right? So it's a great opportunity, really. So it's very forward thinking. We've just got to get the IP issues and so forth and the technology issues correct.
Yes, Casey.
So Congressman Reed alluded to this morning there was a state of the steel industry address. And this technology is so different than the traditional manufacturing. Can you say a little bit about the material supply chain and how that might be impacted?
I'll go again. Actually, we have something called Team Sunrise that gets together at 0530 over at Oak Ridge, and this is like nobody bothers us, and we just drink a lot of coffee and talk about these things. So, in fact, actually, what additive does, right? So, if you go out there and say, oh, like, I want to use titanium, you can look up titanium. There are hundreds of titanium alloys out there. You can only really buy 3. Why? Because, you got to melt tons of the stuff to make it, right? You can't just say, I want a pound or 2 pounds of this titanium. But now, as you start to talk about additive, look, I don't need, sort of big ingots. I can 3D print, an engine. It's not as efficient, right? But I can print an engine, I can print a turbine blade and so forth. So I can actually, it's almost like a, little micro foundry there to put it together. So what would happen there is you could say, okay, yeah, let's start to, okay, we have this new alloy, we'll print it, we'll use it. And then at some point in time, it allows us to say, oh, I'm using enough of this, I can go back to the U.S. steel industries, to the foundries and so forth, and say, instead of just wanting, a couple of tons, I need hundreds of tons because it's not going to go into, I'm going to scale my production up from, let's say, my really high-end, vehicles, down to my more general vehicles. So it actually, I think that it also gives us a path forward, all right, to go from the benchtop, so what we would call the lower technology readiness levels, to more of a larger scale production. It's actually pretty phenomenal in terms of how we're able to pull this off.
So I'm just gonna keep following
Yeah.
with you starting these things. The U.S. Army asked us the exact same question. They said, you know, we're really struggling to understand like how to prioritize what vendor we want to go procure from, how to actually get the material supplier to integrate with someone like Lockheed Martin, for example, how to get the specs and standards into the lower chain supply chain partners, et cetera, et cetera. And they actually have funded a 3-year program. It's actually just kicked off through us to actually go build out the future state supply chain. And so stay tuned for that, because I think we're going to start reporting out on kind of how that's going to go. The good news is Congressman Ryan was very supportive of this, and so it's actually focused right now in the Tech Belt, which is Ohio and Pennsylvania. We're trying to prototype and pilot that we can build out a fully end-to-end supply chain capability for the Army so that they can fly with confidence. But the point is that we can then deploy that model across other pockets around the country.
Questions? Yes, please.
So you all were talking about the demand for workforce with regards to advanced manufacturing and the training of workforce. Well, so I have a kind of a multifold question here as far as recruiting that workforce and starting young, and also making sure it's a diverse workforce. I know, so I'm a AAAS fellow, or not AAAS fellow, whoa, Tech Congress fellow, and so my background's in robotics, and I know a lot of engineers kind of have that one moment when they're younger, you know, that was inspiring for them to get into engineering. What can we do to do that, and then what can we do to capture those young minds?
I want to tell you a funny story. I've got a 12-year-old at home, and when he was in the first grade, I took a printer to his first grade school.
Yeah.
And I was very intimidated because to the left of me I had the local pizza guy, and to the right of me I had what I call Jungle Jack. He brought snakes, armadillos, and a porcupine. And right in the middle was me with the 3D printer, and I was like, you know, how's this going to go? And I have photographs of, one, there were more women, girls than boys coming up and want to interact with the printer. And two, the pizza guy had a ton of pizza left over because nobody wanted to play with what he had, which is free food, because they wanted to interact with us. The technology is so easy to understand by these young minds that it gets people excited. So we're working with, for example, another institute called LIFT, where we're trying to deploy programs into elementary schools, middle schools, high schools. You know, we talked about K to 16, you know, it's getting into the education, the higher education, but we're also talking about vocational tech. You know, these institutes were stood up with the sole purpose of doing that. Oak Ridge does a tremendous amount of work in education, but I typically hear from them to say, but our charter is not really to do that. We do it because we have to and we care about it. And so, you know, I think there's a huge opportunity. I'm sure Michael does the same thing, like, you know, going into schools. But all of us need to, you know, to the Congressman's point, we all have to find, if we care about education, we have to find a way to do it and not expect someone else to be a part to give us the answer, right? And that's how we've been trying to explain to our members, you kind of got to give back sometimes. And I'm not wanting to sound preachy either, but it is that important. It's really incumbent upon all of us to find a way to take what we know and love and figure out a way to integrate that conversation into the national narrative around education.
You know, I can just add that the scanning that we do, I mean, it's very touchy-feely. It's very, you know, we're making, you know, trinkets in some cases, but it takes some of that to get their interest, especially at that age, and you know, fire them up. And some of these things do that, so that's why we do take these things out to the school. We do go to the STEM programs within the school. We take in interns as part of our company on a regular basis. We're working with several of the community colleges in the area as well. There's this network, I'm hoping everybody's familiar with it. It's called the Fab Lab Network.
Yeah.
It's national. It came out of MIT, Center for Bits and Atoms. Fabulous thing. Every city, I would say most cities probably have some, well, not just a real Fab Lab out of that program, but many other types of Fab Labs or maker spaces, these types of things, certainly in libraries and clubs and community centers and whatnot. But I like to think that that's a lot of where those sparks happen, right? Those parents take their kids, they get engaged, and maybe it happens.
And oh, by the way, we partner with Fab Lab to actually deploy a digital badge, and we're doing it across 10 cities in digital Fab Labs with the intent that we'll actually deploy that digital badge across the entire network around the world. to give them some recognition that their interaction with the process is actually credentialed to some level.
I'll add on to that. Times are different, and the kids that they are learning differently. They'll Google stuff, they'll look stuff up, and really it doesn't matter, where your economic background is, because they have access to these things. They're coming into universities and they're programming Arduinos and so forth. I mean, I had one kid, who basically, my coffee, he actually wanted to monitor a liquid level system, and he's trying to get us to, we're not on record, are we? Okay to monitor, my department chair came in and said, why is there a Wi-Fi antenna coming out of the bathroom? I'm like, no, you can't do that. So our coffee makers are now online, right, for like $2.50, right? And they tell us when they're empty, if it's hot and so forth, and it's actually very cool. And they just said that it's just sort of a fun project. But the other thing I think it's very important, is not just, educating and exciting the next generation, but it's the current generation as well. And again, like the VR technology and so forth, you make it accessible. When I was a kid, the joke was the parents had the kids program the VCR. Now, you've got your Fire TV, it's got a couple of buttons on it and so forth. My mother can, she's 80 years old, she can do that, right? I mean, if you simplify it, the interface is great. The smartphone, I mean, it's changing life. We're implementing stuff with smartphone technology in manufacturing, and almost everybody, has a smartphone, and they're comfortable with it and so forth. And, to give you a feel from a cultural perspective, my mom, 80 years old, about every 10 years gets a new car. She just bought her latest new car, and she said, this is going to be my last one. And because, that's it, I'm going to stop driving. And it's a little sad. And I said, no, but you know about Lyft, and you know about Uber, and you can use it. And so all of a sudden, that's a game changer. And we see the same thing, again, not only for the current generation, and they are excited about VR and all this sort of stuff, but also, the next generation, but also the current generation. So we're engaging them as well, so they're not going to be left behind, which is exciting.
Well, yeah, and actually, sorry if someone else wants to, you hit the nail on the head for, my next question was around reskilling, too, for the current the generation that is maybe, as far as manufacturing, it's getting phased out a little bit. How are they going to level up and start training? And what programs have you heard of that are working? And
Sure. So, there are a number of programs. I know the federal government is reaching out, to professional societies like ASME and like SME in terms of their training and so forth. There have, in the previous administration and this administration, supporting a lot of manufacturing education, programs, both in 2-year and 4-year colleges. Veterans, that's another one. Look, as a taxpayer, we're investing so much, right, into our military and the training of our military. When they come out, for just a small little investment, right, you can train them up. It's great for the workforce, we need it. It's great for these people who have given, years to our country, and frankly speaking, in terms of return on investment, I paid a lot of money to train somebody to fix an F-18, right? Now to turn them over to Delta Airlines with a little bit of training, it's awesome, right? And that's exactly where it should be. So I know you've got some stuff going on.
Yeah, we did a program with Google. Our proposal to them was, hey, there's an entire homeless community of veterans in Los Angeles. And that's so irresponsible for us as a people to let that happen. Like, how does that happen? They gave us a couple $100,000, and we went out there and set up shop, and over 3 weeks, not only did we teach them life skills, we taught them how to use the 3D printer, and then they all got hired. What a great success story. So we actually put this in our report to Congress that we did 2 years ago. So if you want to dig back and look at the Manufacturing USA report to Congress, you can read about that story. Those are things that's low-hanging fruit. A couple $100,000 to change people's lives, and now all of a sudden that's a scaled program because we've done it, and we can go put it wherever we want, once we find those communities.
The industry needs it, the economy needs it, the national security needs it, and it's just the right thing to do.
Yeah. What was that program called?
It was called 3D Vets is what it was, and we actually partnered with a company called.
But and Saeed, he apologized. He had to leave to catch a train, so he said take over. So I'm in charge now, right? So, but anyways, anyone who's old enough to remember that one can laugh. All right. And what more questions? Is there one more question? If not, boy, it's just like in my class, right? Nobody ever wants to ask the last question. All right, well, I think we'll be around for a little bit. And also, let me tell you, if you have an opportunity to come out to Oak Ridge and you want to see our operations, I'm sure the same thing for America Makes. And I can tell you, go to Direct Dimensions website. That's some very cool stuff out there as well. But, we really have some capability. We should be leveraging it here in the nation. All right, well, listen, I want to thank you very much for your time here. And I want to thank, everybody for organizing. And thank you to the staff people from ASME and so forth. And once again, thanks for your time.
If anybody has any of the prints, bring them up. I appreciate it.